I had been asked a question to differentiate the questions by the first principle method. By the way, here if we apply other methods than the first principle, then it's going to be really short. But as the question is asking, we have to solve by the first principle method. No problem. First, I'm going to solve this one, and then I'll work on second one. All right. So the first question is y. You can write f of x also. All right. That's same thing. It's ax plus b to the power n. Okay. So what I'm gonna do, I'm just gonna suppose a small increment, I'm just gonna suppose delta y and delta x as a small increment in x and y. So therefore what I can say that it's y plus delta y, as y got increased by delta y, and similarly a, and this x got increased by delta x, so it's gonna be now x plus delta x, all right, and then plus b. I have written this now ax plus b, and x has got increased by delta x, right, and then whole to the power n. Further, delta y I'm writing this side, and this y I'm going to write here. So it's going to be now ax plus a delta x plus b to the power n, and now when this y will shift, it will be minus y. But my dear friend, what is y? Y is actually ax plus b to the power n. So why should not I write directly that? Ax plus b to the power n. Now what can we do? As usual process, let's first divide by delta x, and let's take limit as a delta x tends to 0. All right, so dividing both side by delta x and taking limit as delta x tends to 0, we will get, first we are going to divide by delta x, all right, here also, and the whole these things also, and then whole divided by delta x. Both sides I divided by delta x, and as I said, I have to take the limit as delta x tends to 0. So limit delta x tends to 0, same here, limit delta x tends to 0. For solving this type of the question, my dear friend, I will not forget to mention a formula here. If we have a formula something like the limit x tends to a, and it is like x to the power m minus a to the power m divided by x to the power n divided by a to the power n. Here m and this m and this n are some integers, all right. Then that time our solution is m over n a to the power m minus n. So what I'm gonna do, I'm gonna transform this thing into this standard formula, and the question is how. Actually I saw one thing here, uh, ax plus b, it means it can be cancelled, and by a, if you multiply here and if you divide by a, then we're gonna form easily, like this. I'm just gonna show you here. It's delta x, right? See what I'm gonna do, I'm going to write here one a and another a I'm going to write here, so that I can cancel this a and nothing will happen. But I'm not gonna do that, because that's my trick. I just multiplied here and then here also, right? Multiplying in numerator as well as in denominator with the same quantity does not affect anything, all right? And now I'm going to plus something here. Check it out what I'm gonna plus it. I'm gonna plus ax, all right? So the same time what I'm going to do, I'm going to subtract ax, and now I'm going to add b, and the same time I'm going to subtract b. So there is no problem at all in doing such, So in next step it will be del 1, and now I'm taking minus common, and it will be ax plus b to the power 1. So now if you see, this is exactly in this standard format, whatever the thing it is, this whole thing I'm talking, this to the power n, and again this to the power n, and again the same thing what is in numerator, this is in denominator here, and same thing here, so our answer is going to be now just like this, m over n. So here this is our m and this is our n, so m over n, and n is here 1, times a to the power m minus n. A is our here ax plus b, so it's ax plus b to the power m minus n, but here m is our n and n is our 1, all right, n minus 1, and this a is leaving here also and here also. So final answer is an ax plus b to the power n minus 1. So this is how we need to solve by the first principle method. If you want, then you can go directly also. Most of the students write like this also. They go by the definition of the derivative. Limit h tends to 0, f of x plus h minus f of x divided by h. So it's the same, all right. Limit h tends to 0. Now see, our function is f of x equals to ax plus b to the power n. So when you insert x, you're gonna get ax plus b. When you insert apple, you'll get a times apple plus b to the power n. So what I'm gonna do, I'm gonna insert here x plus h instead of this x. So this will be x plus h. So in the same way, it will be a times x plus h plus b to the power n minus ax plus b. All right, simply to the power n, because f of x it is, all right, to the power n, and then divided by h. All right, now it will be ax plus ah plus b to the power divided by h. So as we did in the previous section here, as we multiplied and then divide by a, and then we try to form in this standard formula. So exactly same we are going to follow here. I'm gonna multiply here by a, so same here I'm going to multiply, and then it is ax, so I'm going to add ax, and the same time I'm going to subtract the same ax. All right, and now I'm going to add b, so I'm going to subtract b. All right, and I'm closing it. So the power is 1 here and the power is 1 here. All right, so now I can directly use the formula. All right, this is the formula that I told you here, this formula, m by n a to the power m minus 1. So it's going to be m by n, this is my m and this is my n, okay, times a to the power, that is ax plus b to the power m minus n. M is here n, so it is n minus, and n is here 1, so it's 1 times this one is left a. So our answer is an ax plus b to the power n minus 1, and that's our solution. So this is how also you can do very simply, shortly, by the first principle method. It's not such a big if you do by this method, right? And I will suggest you to go by this method also, but I was just trying to make you understand more the basic concept, how this all came,